This is the first in a series of videos on permutations and combinations. And when we're talking about permutations and combinations, we're looking at problems that are often described as n objects taking r at a time. Another way to think about this, I call these sum for many problems. And the idea here is that you have a larger group, and from that larger group you're going to choose some of them. And the question is how many arrangements are there possible of n objects chosen r at a time? And let's look at a pretty simple example. Let's say you had 5 pairs of blue jeans, and let's just letter them A, B, C, D, and E, and you were going to choose 3. Well, obviously one possibility would be to choose A, B, and C. Another possibility would be to choose A, B, and D, and another possibility would choose A, B, and E. And you think about these are 3 different combinations of 3 genes among these 5. And that's the type of problem we're going to talk about. Now obviously this problem turns out to be more difficult than just listing them all out. And also we need to think about whether or not choosing gene A, B, and C is the same or different than choosing the genes B, C, and A. That is, does order matter? And whenever you have a problem like this of n objects taking r at a time, the key question becomes, does order matter? And we want to look at 2 simple cases. One case where order matters and one that when order doesn't matter. And it turns out that when order matters or when order doesn't matter, it's either called a permutation or a combination. So let's look at the case. In example number 1, we're going to choose, let's say 120 people go to a dance. And you have a drawing. And you have 3 winners. Right? Let's just say you have a jar, and everyone puts a ticket into the jar. So there's 120 tickets, and you're going to choose 3 possible winners. And the question is let's say each winner gets a free pass next time. So they don't have to pay for the dance, they go the next time. This is a real world case. I did this last weekend, right? 120 people come in, there's 120 tickets, you pull out 3 winners from a hat, or from, in this case, a jar, and each one of the winners win a free pass. And then the question is, does it matter if you were the first person that won, or the second person that won, or the third person that won? And in that case, the answer would be no. Order doesn't matter because each one of the winners get exactly the same thing. Let's look at a second example. In the second example, let's say that you had a race, some type of contest. You could take all the math students at a high school and line them up, and you could have a foot race. And let's say that first prize gets a new car. And second place wins $20,000. And third place gets not 1 but 2 chocolate bars. And the question is, would you care? Would it make a difference to you if you came in first place, second place, or third place? So does order matter? Well, the question of whether order matters depends on whether or not winning a new car or $20,000 or 2 chocolate bars are different for you, and most assuredly they are. But because even though 2 chocolate bars are nice, they're not as nice as a new car. So in this case, clearly order matters. And that's what you're doing. If you look at the structure of these problems, they're the same, right? Here you have 120 people, and you're choosing 3, and you're asking how many different possibilities are there of 3 winners. In that case, order does not matter. In the second case, you have, we didn't specify, but let's say you had 300 people in a foot race. They're all lined up. And you have first, second, and third places win these prizes. In that case, clearly, there's a distinct difference between coming in first place and third place, so that order does matter. And now let's give it some vocabulary. So whenever you have a problem of n elements chosen r at a time, then we're going to say if order matters, we're going to say that it's called a permutation. And if order doesn't matter, we're going to call that a combination. And the formulas that we're going to use are going to end up being NPR and NCR, where the P here stands for permutation and the C here stands for combination. And we've covered those in the last one, we'll cover those in the next video. But here the key elements is, the key facts to remember is that we're solving problems where we're choosing n objects, taking r at a time. Or another way to say that is we're choosing some from a larger group, some from many problems. And the key question is does order matter or does order not matter? If order matters, it's a permutation. If order doesn't matter, it's a combination. That's the end of this video, and next you're going to watch Permutations and Combinations, Part 2.